Good morning on this lovely Tuesday. Hopefully you had a great weekend and you survived Monday. As I was writing in the chat before the show started, and I feel like survival on Monday is almost the best you can hope for. Mondays, you're just like coming out of this awesome weekend mindset where you can have all the time you want to do whatever you want. And then Monday, it's back to the grind in your four walls that you stare at probably every day, most of the day. So, you have made it to the OscopeWizard show. I am the OscopeWizard. I'm Gabe. Welcome. Thanks for joining me in the Techno Lair. We are on a quest. We're on a quest. If you have been watching the show along with me, and hopefully you have, and if you haven't, guess what? The shows are all archived in the playlist. You can just follow right along. But if you've watched the show, you'll know that the quest is to build a DIY Sonos Style amplifier out of a Raspberry Pi. This is the star of the show, the Raspberry Pi Zero. That's what we're doing here. This is an extra one that I may or may not use in the final product. We'll find out. I don't know. Since the last show, though, I've made some upgrades. I have made some upgrades since just last week. It felt like eventually, we were going to need to put this stuff in a box. So I bought a box because I'm not a great carpenter. So I bought just an empty box from Amazon. You can see it flips open. It has a hinged lid. It has fairly thin sides, which is good because I need to drill holes through them. And we need to put a power supply inside of it. And eventually we need to put some kind of a power connector inside of it. We have components, the amplifier, the actual amplifier. We have a DC to DC converter. We have the Raspberry Pi. We have a DAC. We have everything that we need to put inside of it. And that is what I have done. I've actually put it inside of this box. Let's take a look at box. So, our DIY Sonos Style amplifier, we have a box! And it's going to be full of nerdy electronic equipment eventually. Let's go over what we have done so far. So, what have we done so far? I think I can type and see it happen all at the same time. We have chosen our operating system. So chosen OS, and that was Moode Audio. We have connected our DAC, which is what was our DAC chip? Our DAC chip is hold on, as I struggle to find it. What is our DAC chip? It's a PCM5102A. So PCM5102A DAC that we connected via I2S on the Raspberry Pi. We have a Raspberry Pi Zero W, which is the Raspberry Pi Zero with the built-in wireless chips so that we have Wi-Fi and Bluetooth. And we have, of course, the TPA31162D2 Amplifier Board. This is the thing that is going to get the noise into our ear holes. So it's going to take the noise and put it into our ear holes. Hopefully. That's the idea. That's the idea. Okay, so that is the story so far. Let's get the chat back up so that I can actually see it. Hopefully the chat's with me today. Hopefully the chat's with me. I have it on good authority that my mom has joined, which is always great. She's like a mini celebrity in the chat, asking the best questions. So this is a picture of the box. You can see in the last episode, we compared rotary encoders and potentiometers. You know what I don't have? And I just realized that I'm sitting here and talking. It is 5 minutes into the show, and what I don't have is my timer. I don't have my timer. So I will need to keep track of time. We're going to need to keep track of time, which is something that I am notoriously bad at, but I'm going to try. So we compared potentiometers and rotary encoders, and we decided that for our case, we need the rotary encoder, and the rotary encoder works with digital inputs perfectly. A potentiometer is an analog system that moves a voltage up and down. This knob that's sticking out of the front of my box is my rotary encoder. In the back of the box, I have a camera on a handle here. In the back of the box, I have my speaker outputs that I've installed, which I'm pretty excited about. And then I also have my power supply, my power cable, can I speak? My power cable, and my power cable has an on and off switch, which is something that we were missing. And every time I turn the power on and off by unplugging and replugging, I'm always nervous, like I will manage to shock myself, which would be both painful and embarrassing. So let's open up the box and check out what's inside. So the box has a hinged lid. It is not perfect, and one of the upgrades I'm planning on making to the box is magnetic pins. I found some magnetic pins to hold up maps and mark places, and I'm going to add those to the corners, and hopefully that'll make a nice snug seal to the box and make it look like it's one piece. Inside I have my power supply, 24-volt power supply. Remember, we started out with a 12-volt power supply, and we decided, let me turn my camera so you can follow me. We decided that 12 volts was not going to provide enough power, so we upgraded to 24 volts, giving me a little bit extra oomph. I have my DC to DC converter. I have one of them. I have a second one on the way because I have a suspicion this might be one of my problem points. But this one is going from 24 volts to 5 volts, which powers my Raspberry Pi right over here. So here's my Raspberry Pi all wired up. The Raspberry Pi feeds into my digital to analog converter chip, my DAC chip, which converts the I2S digital signals into an analog audio signal. The analog audio signal feeds into my amplifier board right here, which is connected to my speakers in the back. Up here at the front, you'll notice this is the rotary encoder that I showed. So here's the front. It's going through the front of the box. And here is the rotary encoder in the back. I have it wired up so that I can eventually connect it. The rotary encoder is kind of cool. It can it goes clockwise and counterclockwise, but it also has a built-in button. So we're going to try to use this button feature to switch inputs. Now, a couple of things I want to add. I realized that most amplifiers have auxiliary inputs, so they won't force you to put everything through your Raspberry Pi. Maybe you just want to plug your phone or an instrument in, or a record player. I don't know what you want to plug into this thing. Something to make noise for your ear holes. So I bought this switch that will switch one of these audio jacks to the output, and you can choose between the two audio jacks. Of course, this is going to be tough to automate since it's a mechanical switch. With that in mind, I also bought this relay that I can control with the Raspberry Pi, presumably. So I should be able to automate switching from one input to the other, and eventually I hope to be able to control all of that with the press of that button. We'll see. We'll see. That is like advanced double black diamond level automation for me. We'll see if the OscopeWizard can handle it. But as it stands, I could close this right now and turn on some audio and actually use this as an amplifier. So I could close that up, hit go. Well, you probably don't want to have wires sticking out the side. But the next, well, goodness gracious, that wire is really wanting to escape. But the next step I felt that we should do on our journey is to connect the rotary encoder, because I would like the rotary encoder to at least control the volume, and it should be pretty simple. Let's start with the rotary encoder. I know that this rotary encoder sends out 2 pulses, so it's two digital signals that need to be connected to the Raspberry Pi. And I have them wired up with these blue wires. So I have 3 wires coming out of the rotary encoder that are not connected. 2 of the wires are connected, and that is power and ground. So the rotary encoder is already energized, if you will. And I'm going to start with the clock and the pulse signals. So these are the signals that handle the direction that I'm spinning the rotary encoder. Am I spinning it clockwise or counterclockwise? And if I go over to my software, my Moode audio, and look over here, inside of the software, so first of all, here's the volume indicator in the software, so I can see more volume, less volume. Inside of the software, if I go to configuration, and I think it's audio, I have my I2S DAC chip enabled. Max ALSA volume. I don't think I need to set that. It'll do 0 because I want the volume to be controlled by software, which is right here. Rotary Encoder. So this little option right here allows me to connect the rotary encoder. It says it will poll these inputs every 100 milliseconds, which is pretty fast. It's slow for electronics, but super fast in human time. The acceleration factor, this is basically how many volume steps it will increase or decrease the volume every time it detects any kind of a step in the rotary encoder. I think that's what it is. Yeah, that's what it is. And then this is how the number of steps to use when the knob turns at a fast rate. So if it's turning super fast, it'll do three volume steps up or down. Now, most importantly, pin A and pin B. This is where I need to connect this device. So I need to connect to GPIO pins 23 and 24 by default. I can change that by changing these numbers, but I'm going to leave it how it is for now and see if I connect it and spin that knob, will it change this volume? If I go back over to my setup here and turn off the desktop, see if I can get it. There we go. So I have my setup. I have my 2 wires that I'm interested in, and I need to connect to GPI 23 and 24. And I guess if I connect it backwards, that just means I need, clockwise won't go up and counterclockwise won't go down, but that shouldn't be a big deal. So I see GPIO 24. Can my wire reach? That would be unfortunate if it didn't quite reach, but not an insurmountable problem. Okay, so 24. There's GPIO 24 and GPIO 23. So I'm connected to GPIO 23 and 24 now. Let's see. Does this work? We'll find out. Is it working? It doesn't seem to be working. Let's make sure I do have it plugged in 23 and 24. GPIO 23 and 24. It does look like I have it plugged in. Okay. And I have this center pin, which is the button push, not connected. Okay, so what I could do is, let's go back really quickly, go to audio, and let's turn the rotary encoder off. And turn the rotary encoder on and hit set. Okay, so now my rotary encoder should be on. I don't know if I would have to reboot. Before we go too crazy, you know what I have? I have an oscilloscope right here. So we could hook up the oscilloscope to make sure that our rotary encoder is actually rotary encoding. Let's just hook up channel 1 over here, and I am going to let's just plug into the top pin to make sure my rotary encoder is in fact juiced. It is powered up and encoding something. So all of that is plugged in. I probably should have switched views. So now I have an oscilloscope probe plugged in. Let's get myself a negative connection. So I have a ground reference. And I can do that like this really quickly. And I'll just connect that here. Now, if I go over to my scope, first things first, everybody knows first things first, preset the scope. Okay, now let's cheat and just hit auto scale and see if it'll find the signal. Found the signal. Perfect. Let's scale the signal a little bit. Right, so 1 volt per division. I'm going to move the signal up a little bit. Oops, not the whole signal, just, all right, maybe I won't. I would like the offset to be 0 volts. And actually the offset, let's make the offset 3 volts so it fits onto the screen perfectly. So now I can see 0 volts and 5 volts, so it's sitting high. Every time I turn this rotary encoder, I should see a pulse. And in order to do that, remember this pulse was pretty slow, so I'm going to crank my acquisition time up. So I'm grabbing a lot of time. Oh, maybe not 10 seconds, but maybe, you know, half a second. Let's grab half a second of time. And let's turn my trigger so that it is in normal because I want it to actually capture the edges. So now you can see the scope is not triggering, it is waiting for me to do something. And if I turn this, the encoder isn't doing anything, which is probably why my volume wasn't working. Interesting. I would say I have something plugged in wrong. If I was to just, oh, there we go. That was interesting. So we got a little bit of an edge. I wonder if that's, I wonder if my encoder is busted. That would be a bummer. That would be a bummer. I hope it's not busted. You know what we can do? What we can do is we can switch it out a little bit. Let's, in order to debug and diagnose a problem, usually I try to simplify the situation. So in the last episode, we confirmed that the rotary encoder at that point did actually work. But now it's not working when I have it all in the box, which has happened so much when you're in electronics or you're trying to do a lab, you're trying to finish it for school. It works, your setup works, and suddenly it doesn't work anymore. And that's a real bummer.
5 minutes left.
It's also a real bummer that there's only 5 minutes left. But that's okay. That is okay. We are going to simplify our setup and just focus on the rotary encoder. So first things first, let's go back to my setup. There we go. There's my setup. Whoop. I hit the button 900 times. I'm going to turn off the power while I disconnect and reconnect things. So the power is off. Now I'm going to connect up the power and ground directly from my little DC to DC converter. Get the Raspberry Pi out of the mix. And we're just going to explore whether the rotary encoder works or not. I'm wondering if I have the power and ground plugged in upside down or something silly like that, which probably wouldn't be great for the rotary encoder. Let's see if I can find, the pinout for my KY, what is it, KY040 data sheet. Just want to see what the pinout is. So it says it is power, ground, switch, pulse, and clock. Okay, so power, ground on the bottom. I have this thing plugged in. Huh. I wonder if I have all of this plugged in backwards. I'm going to try to make some connections and see if, let's make some connections and see if we can get it going. So let's remove this pin because I believe that is definitely the button. The one in the middle is the button. Power and ground. Okay, so if the data sheet is to be believed, and my mirroring images is to be believed, I believe this is power and ground. Now if I connect this up, I think that is to be believed because when we were connected, it was going high, like the rotary encoder was high and not low. So that does make me think that the power and ground was hooked up in the right direction. If I turn this back on here, get my 5 volts going again, check out my rotary encoder. Here we go, here we go. Now it's encoding. It was not encoding before. Let's continue the experiment here. So power was coming from the Raspberry Pi, so let's try that again. So maybe I had that plugged in incorrectly. So I will connect to let's connect ground first. So ground first. Ground, and now power. So let's find my 5 volt signal. Here's a 5 volt signal. So I have 5 volt and 5 volt. Now let's connect my Raspberry Pi up. Let's first plug in ground. So you can see the Raspberry Pi doesn't have any lights on it yet. And as soon as I connect this cable, it should light up, I would say like a Christmas tree, but not really like a Christmas tree. More just like a light, a tiny LED light. Now, if I connect this and turn, there we go. Now my rotary encoder is encoding. You can see if I go back over to my scope, let's turn my scope on, you can see, well, I say that, if I bring the scope up to the front, now you can see, look at that, as I spin it, you can see pulses, which is exactly what I want to see. So now the rotary encoder is encoding. So if I go back to my original goal, which was just to connect up these 2 pins, clock and pulse pins from my rotary encoder to, I need to connect them to GPIO 23 and 24, if I'm not mistaken. So this is 1 pin, and I will connect that to GPIO 23, I believe. No, I'll connect that to GPIO24 because that's the farthest one away. Can I get it? Can I get it? No. Can I get it? Yes. All right, 20, that's GPIO24, and now I'll connect the other one to GPIO23. It's a big episode. We got the rotary encoder plugged in. Does the rotary encoder work to control the volume? We will find out. Let's see if it's going to control the volume or if it's going to be something a little bit more exciting. Let's go back to... Look, there we go. I have it plugged in backwards because counterclockwise is clockwise is making the volume go down and counterclockwise is making the volume go up. But the rotary encoder works. Yay! It's a miracle. It's a miracle. So now that we have the rotary encoder working, the next episode, we are going to connect up a speaker and we are going to see how clean the output is when no audio is coming out. When I was experimenting with this over the weekend, when I hooked up the speakers, there was some weird noise that was just bubbling inside the speaker, even though nothing was playing. And that would be unacceptable because we don't want random noise coming out of the speaker. So tune in next time. We're going to do a little bit more diagnosis of a power supply noise problem, I think is what it's going to be tied to. This would be like conducted EMI, electromagnetic emissions, because it's conducted because it's connected. So my power supply is creating emissions and it is actually getting out into the world in an audio signal through the speakers, which is not great. So join me. I don't know all the nerds in the world and I would love to meet them. So please share this with a nerd in your life. And I will see you guys next time. Take it easy. Bye.